Hi, my name is Rohit Pasula, and this is my video for Lab 2, Charge Tapes as a Line Charge. The objective of the lab is essentially to observe and calculate the excess electric charge on one piece of charged clear Scotch tape, as well as to visualize the physical behavior that the different charges have on the tape. We will create a computational model through a program called GlowScript and determine the calculations needed for the magnitude of the electric charge. The fundamental principle demonstrated throughout the lab is Newton's second and third law of motion, as well as calculating the electric field from a distributed charge. The concept of Coulomb's law is prevalent in this lab too. The procedure of the lab includes creating a U-tape. To do this, you take two pieces of tape, set one as the base tape and place another tape on top of it, then quickly take it off. To make sure that the tape is negatively charged, use a plastic pen and observe repulsion. Now repeat those steps with another pair of tapes. Finally, hover one of the U-tapes over another and measure the distance of separation. This value was 1.8 centimeters. Now, before heading into our computational model, there are a couple of assumptions that we must address. For the sake of the model, we will be assuming that both pieces of tape are completely identical in size, shape, and matter. This also means that each tape has exactly the same charge. We will be viewing the tape as a line charge and be using superposition. Regarding other forces that may be involved in the experiment, they will be negligible. Most importantly, air resistance and drag force. Now, before developing the code, we must set the constants and variables corresponding to them. These constants include g, the gravitational constant, which is 9.81, k, Coulomb's constant of 9 e to the 9th, the mass of the tape, 1.99 e to the negative 4th kilograms, the charge of a proton, as well as the estimated charge found on one tape when viewed as a point charge, which we calculated from Lab 1. Regarding the actual code used to calculate the magnitude of the electric charge, I first created a function to calculate the electric field at one observation location. This function would be later used in a for loop as a means of superposition to add all the point charges together. In the for loop, I iterated through each piece of charge on the top tape as well as the bottom tape. I also calculated the electric field and the electric force at the location of the top tape on the bottom tape. Finally, I generated an arrow to show each of these electric fields. So as you can see, the model generated is to the right. The electric field vector only pointed in the y direction and had a magnitude of 1.607 e to the 4 newtons. The magnitude of the electric force was 1.957 e to the negative third. The magnitude of the gravitational force was almost identical with the magnitude of 1.953 e to the negative third. So for our reflection questions, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So the charge for the tape when viewed as a point charge was 2.69 e to the negative 9 coulombs, while for a line charge it was 1.957 coulombs, e to the negative 8 coulombs. As you can see, there was an increase in charge when viewed as a line charge because of the superposition of adding all the charges together. Now, why do these estimates differ? Which value is more likely to be closer to the real value, and why? The magnitude is much greater for the line charge compared to the point charge. This is due to taking into account a larger surface area. The line charge is closer to the real value as objects are not considered to be point charges in reality. Every area on the tape has a charge. Thus, using the line charge magnitude will provide a better estimate. Superposition allows the charges to be distributed among the tape. Thus, the charges, although not as concentrated, the overall charge is still much greater compared to the point charge. All in all, this experiment allowed us to differentiate the concepts between a point and distributed charge. Thank you for listening and have a great day.